Hey everyone, and a huge welcome to all you first-year computer science students joining this explainer. I am honestly so thrilled to have you here. Think of me as your personal mentor today, right? We're going to demystify the invisible building blocks of modern software together. You are right at the starting line of a pretty fascinating journey into development, and today we're looking at the absolute foundation of how the digital world communicates. Trust me, it's going to completely change the way you look at literally every piece of software you use from here on out.
Okay, let's dive into this. Imagine you open up the weather app on your phone. Bam! Instantly you've got today's temperature, humidity, wind speed, and even a forecast for the whole week. But where does all that information actually come from? Your phone obviously doesn't just magically know the weather. There's no tiny meteorologist living inside your screen, right? Instead, the app relies on an invisible bridge to go out and fetch that data from an external service. And that bridge, that's what we call an API, or Application Programming Interface. So here's our roadmap for today. We'll cover 1. The waiter of the web. 2. Anatomy of API requests. 3. Decoding the server response. 4. REST versus GraphQL. 5. Security, testing, and tools. And finally, 6. The developer's essential manual.
Part 1. The waiter of the web. Let's move away from the magic of apps for a second and look at the practical reality of how these systems actually talk to each other. To really wrap your head around an API, just think of a restaurant. When you sit down at your table, you don't march right into the kitchen, grab a knife, and start chopping veggies for your own dinner, do you? No, you, the client, don't do the heavy processing yourself. You look at a menu and you tell the waiter what you want. The waiter takes your request back to the kitchen cooks the food, and then the waiter brings that finished meal right back to your table. Well, in the digital world, you or your app are the client. The kitchen is the server. That's where the actual heavy lifting happens. And that waiter? Yep, that's the API. It takes your request, talks to the other system, and hands you back exactly what you ordered.
Moving on to Part 2, Anatomy of API Requests.
And this brilliantly illustrates our next point. Just like ordering food means you need to speak a language the waiter understands, APIs have their own grammar. Almost all API communication is built on a super simple three-step dance. First, the client sends a request. Second, the server processes it. Third, the server sends a response. Think about a standard social media login. When you log in, your app sends a request carrying your username and password. The server checks those credentials, and if they match, it responds by letting you in. Boom. It really is that straightforward.
But, how do we actually ask for different kinds of things? Well, we use what are called HTTP methods. Think of the API's endpoint kind of like a physical house address. The method tells the server what action you want to perform once you get to that address. So GET is used to just retrieve information, like opening an online store to browse a list of products. POST is used to create something brand new, like when you fill out a form to register a new user account. Then you have PUT, which replaces existing information entirely, while PATCH just updates a tiny part of it, like if you're only changing your phone number on a profile. And delete? Well, as you'd guess, that removes information completely, like permanently deleting an old account. These methods are the standard verbs that tell systems exactly how to interact.
All right, Part 3. Decoding the server response.
Because every good conversation needs a clear reply, right? You've asked the server to do something, so how does it tell you what actually happened? So the crucial point is understanding these status codes. Think of this as your ultimate developer cheat sheet. Pros use these numbers literally all the time for debugging. Let's use a standard office scenario to make this stick. A 200 OK code. That's like asking a coworker for a file and they hand it right to you, no problem. A 201 created is when you ask them to make a new folder and they say, done, it's filed away. But what about errors? Well, a 400 bad request is like handing that coworker a form filled with absolute gibberish. They just stare at you completely confused. 401 and 403 basically mean you don't have the security clearance to go into the manager's office. A 404 not found, that's walking up to your coworker's desk only to find they've moved and the desk is totally empty. And a 500 internal server error. Yeah, that's when the office printer literally catches fire. Something broke on their end, not yours.
Now, when the server does respond successfully, it usually sends data back in a format called JSON. And please, do not let the full name JavaScript object notation intimidate you. You're going to use this in pretty much every programming language you touch. JSON is simply a remarkably clean, lightweight way to organize data so both humans and machines can read it easily. It structures things super logically by pairing labels like name, email, and age directly with their values. It is, without a doubt, the universal language of API data transfer.
Which brings us to Part 4,
REST versus GraphQL.
Let's move to and see how this builds out in the real world. As you start designing these digital conversations, you'll run into different architectural styles. Now, REST is the industry standard. It's simple, widely used, and it powers the vast majority of web apps you use every single day. But REST has a bit of a quirk. Sometimes it overshares. Imagine asking an API for a user's name, and it sends back their name, their home address, their entire purchase history, and even their dog's name. That's a lot of extra data. GraphQL was created to solve this exact limitation. With GraphQL, the client can ask for exactly the specific data it needs and nothing else. They're both incredible tools, and honestly, as a developer, you'll just choose the one that fits your specific project.
All right, on to part 5, security, testing, and tools. Look, with all this amazing connectivity, we absolutely need safety and reliability. We have to establish the rules of engagement. I mean, if an API connects to people's bank accounts, you can't just leave the front door wide open. And that brings us to a huge, absolutely vital distinction: authentication versus authorization. Picture a secure corporate office. Authentication is the ID check at the front lobby. It answers the question, who are you? Authorization is what your physical security badge actually lets you do once you're inside the building. It answers, what rooms are you allowed to enter? To handle this digitally, APIs use tokens. Think of a token like a temporary digital key. Once you prove who you are, the API hands you this key, which gives you specific access for a limited amount of time. It's brilliant because it keeps sensitive resources locked up tight from malicious actors.
But hey, even with ironclad security, developers are still human, right? Code is gonna have bugs. That's exactly why we rely on powerful tools like Postman to test APIs inside and out. Long before real users ever touch an application, developers are firing off test requests, double-checking those status codes we just talked about, and measuring performance. We do all this to catch bugs early in a safe sandbox environment. Because, trust me, a single API failure out in the wild can crash an entire service and impact millions of people. Testing isn't optional, it is your ultimate safety net.
And finally, part 6, the developer's essential manual.
Now, what's really interesting about this slide is how it ties everything together. We've looked at how APIs work, how they're structured, and how we keep them safe, but there's one last piece that actually makes them usable for other humans. Imagine buying a super complex piece of heavy machinery, but it doesn't come with an instruction manual. It would be completely useless to you. Well, the exact same logic applies to software. API documentation is that essential instruction manual. It lists all the endpoints, the proper request formats, and every error message you might run into. Having clear, concise documentation is the true hallmark of a great API, simply because it respects the developer's time and makes integration an absolute breeze.
From weather forecasts and processing payments, all the way to your social media feeds and AI models, APIs are the invisible threads holding the entire internet together. They are what allow all these different systems to talk to each other seamlessly. As first-year students, getting this concept down isn't just about passing your next exam. It's a massive shift in how you view software as a whole. Like the quote says, if you understand APIs, you begin to understand how the digital world truly works. So, now that you hold the keys to the digital conversation, what will you build next?
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to FuturE BreaK CodeR, because many exciting coding and futuristic tech videos